An SSD is usually used in conjunction with the use case descriptions to help document the details of a single use case or scenario within a use case. To develop an SSD, it is useful to have a detailed description of the use case, either in fully developed form or as an activity diagram. Like this one. These two models identify the flow of activities within a use case, but they don't explicitly identify the inputs and outputs. An SSD will provide this explicit identification of inputs and outputs. One advantage of using activity diagrams is that it is easy to identify when an input or output occurs. Inputs and outputs occur whenever an arrow in an activity diagram goes to an external actor to the computer system. So notice this activity diagram for create customer account. So there are two swim lanes, the customer and the computer system. In this instance, the system boundary coincides with the vertical line between the customer swim lane and the system swim lane. The development of an SSD based on an activity diagram falls into 4 steps. The first step is to identify input message or messages. So in this figure, there are 3 locations with a workflow arrow causing the boundary. So first is this, and this one. At each location that the workflow crosses the automation boundary, input data is required. Therefore, a message is needed. The second step is to describe the message from an external actor to the system using the message notation. So in most cases, you will need a message name that describes the service requested from the system and the input parameters being passed. So here, this is the SSD for the create customer account use case. So this illustrates the 3 messages based on the activity diagram. So notice that the names of the messages reflect the services that the actor is requesting to the system. So the create new customer, enter address, and enter credit card. Other names could also have been used. For example, instead of enter address, the name could be create address. So the point to remember is that the message name should describe the system requested from the system and should be verb-noun form. The other information required is the parameter list for each message. So determining exactly which data items must be passed is more difficult. In fact, developers frequently find that determining the data parameters requires several iterations before a correct, complete list is obtained. The important principle for identifying data parameters is to base it on the class diagram. In other words, the appropriate attributes for the classes are listed as parameters. So looking at the attributes along with an understanding of what the system needs to do will help you find the right attributes. With the first message just mentioned, the create new customer, The parameters should include basic information about the customer, such as name, phones, and email address. Note that when the system creates the customer, it assigns a new customer ID and returns it with the customer information. Here, the customer ID, the name, phones, and emails. So this is the return value. In the second message, so the enter address parameters are needed to identify the full address. Usually, that would include street address, city, state, and zip code. The SSD simplifies the message to show just address as the parameter. And here, in the third message, based on the activity diagram, enters the credit card information. So the parameter CC info represents the account number, expiration date, and security code. The third step is to identify and add any special conditions on the input messages, including iteration and true false condition. So in this instance, the enter address message is repeated for each address needed for the customer. So the asterisk symbol in front of the message is shown. The fourth step is to identify and add the output return values or messages. So remember that there are two options for showing return information. As a return value, just like with this, on the message itself, or as a separate return message with a dash arrow. So the activity diagram can provide some clues about return messages. So in this case, for example, with this, the return value should be the address, just like what is shown here. So here, the return value is this address details, and this one with the dash arrow is also a return value. So those are the two ways to show the return value on the message. So there is no standard rule that when a transition arrow in the workflow goes from the system to an external actor, that an output always occurs. So going back to this example, there are three arrows from the system swim lane to the customer swim lane. So in this figure, these are shown as return data on the dash line for two returns and a return value on the same line as the message for enter address. So note that they are each named with a noun that indicates what is being returned. So sometimes no output data are returned. So remember that the objective is discovery and understanding. So you should be working closely with users to define exactly how the workflow proceeds and exactly what information needs to be passed in and provided as output. So this is an iterative process, and you will probably need to refine these diagrams several times before they accurately reflect the needs of the user.